Hi folks, we're going to take a look at number 19 from page 387. So we're dealing with a rectangle with vertices A, B, C, D, and they give us some information about three of the vertices, and they want us to find the fourth vertex in part A, and in part B they want us to find the angle between the diagonals. Okay, so again, I'm going to set up a diagram here without worrying about being accurate, but I do know that it's a rectangle. So I'll try to draw that out. Okay, so here we'll say this is B. So 2, 6, -9. Okay, C. So remember when they give you A, B, C, D, this is the order in which they're joined. So A joins to B, joins to C, and so on. So here we don't know C, so we'll call it X, Y, Z. Okay, and then we've got D, okay, which we know partly its components. So 3. An unknown component of Q, and then 8. Okay, so this is where we ask ourselves, what does it mean to be a rectangle? So we know that opposite sides have to be equal and parallel, but of course it's a little more than that, because we also need adjacent sides to be perpendicular. Okay, so we'll see if we need that information. If we don't, then it means we could have just dealt with this as a parallelogram. But if we have to use that information about adjacent sides being perpendicular, it means it was important to know that it was a rectangle. Okay, so I'm going to start first of all with that first idea that if I join vectors AB and vectors DC, these vectors need to be equal, okay, meaning that they're parallel and they also have the same magnitude. Okay, so here I'll start with that. For part A, I'll say that vector AB has to be equal to vector DC. Okay, and see where that takes me. So vector AB, so again, second minus first, so 2 minus -1 is 3, 6 minus 2 is 4, and -9 minus 3 is -12, and that's got to be equal to DC, so X minus 3. Here we've got Y minus Q. Okay, so we got two unknowns there. And then we have Z minus 8. Okay, and what we can infer by the fact that these two vectors are equal is that their components all have to be equal. Okay, so that means X minus 3 has to be equal to 3. That means Y minus Q has to be equal to 4. And Z minus 8 has to be equal to -12. But this is pretty good because I can determine X and Z directly here. So X has to be equal to 6, and then Z has to be equal to, so -12 plus 8 is -4. Okay, so we've got two of the three components that we're looking for. So clearly it wasn't enough to just use the fact that opposite sides have to be equal in length and parallel. Okay, so what we need to use now is the fact that adjacent sides need to be perpendicular. Okay, so this is where we remember that nice property of the dot product, that we know that the dot product of two perpendicular vectors has to be equal to 0. So I've already got this vector AB, which I can determine exactly, which we've already done. So I know that that needs to be perpendicular to this vector AD. Okay, so that means that AB, when I dot it with the vector AD, has to be equal to 0. Okay, because it's a rectangle. Okay, so AB we've already found, so that's 3, 4, -12. And now let's find AD. So again, 3 minus -1 is 4, Q minus 2, and then we've got 8 minus 3 is 5, and that's got to be equal to 0. And here, given the fact that we only have that one unknown, makes me think that we should be able to solve that. So here we've got 3 times 4 is 12, plus 4 times Q minus 2, so it's going to be 4Q minus 8. And then here we've got plus -12 times 5, so that's going to be minus 60. Okay, equals 0. So here we've got 4Q equals 2. 12 minus 8 is 4. 4 minus 60 is -56. Bring that to the other side, becomes positive 56. So Q needs to be equal to 56 divided by 4. That's 1. 16 is 4. So Q is 14. But now that I have Q, I can go back to this equation here and determine Y. So now I know that Y has to be equal to 4, bring the negative q to the other side. So minus 14 becomes plus 14. So y is equal to 4 plus 14 equals to 18. Okay, so for part A, okay, we found that the point is going to be, so x, y, z. So here we've got 6, 18, negative 4. Okay, so there's our answer for part A. Okay, but I'm pretty sure we're going to need to use D. So let me specify here that D then is going to be equal to 3. Q we just found out was 14 and 8. Okay, so let's move on to B here. Okay, so in fact, let's write this out. So 3, 14, 8. And then C was 6, 18, negative 4. Okay. What we want to do now is we want to determine the angle between the diagonals. Okay, now here this is a geometry problem. We actually don't care about directions of any vectors, so I need to join opposite vertices. So these are the two diagonals. Okay, and usually when we talk about the angle between diagonals is we take their the angle between 0 and 180. Okay. Sorry, we take the angle between 0 and 90. Okay, so we'll take the acute angle, whichever that is. Okay, but of course, in order to determine these one of these angles, I need to work with vectors. So what I'll do is I'll form the vector BD and the vector AC, and this is what I'm going to use to find the angle between those vectors, which will help me find the angles between the diagonals. Okay. So how do we find the angle between vectors? Well, this is how we're going to use dot product now. So what we're going to do is we're going to take the dot product of AC dotted with BD. Okay, and we know that that's equal to the magnitude of AC times the magnitude of BD times the cosine of the angle between them. Okay, so this is where we combine. We're going to combine the two definitions for the dot product to help us find this angle. Okay, so AC, first of all, let's find AC. So AC is going to be, well, 6 minus negative 1, so it's going to be 7. 18 minus 2, sorry, I don't know if you can see that, that's 16. Okay, and then negative 4 minus 3, so negative 7. Dot that with BD. Okay, so let's look at BD here. So 3 minus 2 is 1. 14 minus 6 is 8. And then 8 minus negative 9 gives me 17. Okay, so that's going to be equal to the magnitude of AC. Okay, so let's figure out what that is here. Okay, so what do we have? We have 7 squared plus 16 squared plus another 7 squared. Okay, so 354, which I'm pretty sure is not perfect square. Okay, so we'll leave it at that. Then we're going to take the magnitude of BD. Okay, so what do we get? We get 1 plus 64 plus 17 squared. Okay, oh, and look what we get. We get root 354 again. Okay, but think about it. This is a rectangle. That shouldn't be surprising that the diagonals should be of equal length. Okay, so that's a bit of a check that we didn't make any mistakes in our calculations. Okay, then cosine of the angle between them. So theta is just going to be equal to cos inverse of, so let's calculate this dot product. So here it's 7 times 1 plus 16 times 8. Okay, and then it's going to be minus 7 times 17. Okay, so we've got 16 over root 354 times root 354, obviously is just 354. And so theta here, let's calculate that, inverse cosine of 16 over 354. And that gives me 87.4 degrees. Okay, and since this is already an angle between 0 and 90, that's going to be the one we'll take. Okay, and so this describes the angle between the two diagonals. Okay, so let's recap how we were able to solve this problem. So number one was to draw a nice diagram. We knew it was going to be a rectangle. We didn't have to be precise because the important thing is the relationships between these sides. And the two relationships that are important is that opposite sides have to be equal in length and parallel, but the other condition is that adjacent sides have to be perpendicular. And those are the two properties we used to be able to solve for all the unknowns. Okay? And then for part B, well, we use the fact that we can use the dot product to find the angle between two algebraic vectors. So it's a matter of finding vectors for the diagonals, and then from there using our dot product to find the angle. Okay, that's it for this one.